Hi all. Here we are going to discuss a numerical problem on node voltage analysis. And here the circuit is given to you. And you are asked to find out the current in each of the resistances and mark the directions. That is what you are asked to find out. Now here, you have to approach this problem using the node voltage analysis. This can also be done using mesh current. But if the question is on node voltage, then you have to use the node voltage technique in order to identify the circuit parameters. So here we are identifying the nodes. So we are having 3 nodes are there, 1, 2 and 3. So one of the nodes we are taking it as a reference node, and that node is this one. So this is at 0 potential. Now we have to assign the node voltages. So it is V1 and this is V2. Now the first thing is writing the Kcl equation for node 1. So it is the current through the 20 ohm resistance is V1 minus 100 because this is at a plus potential and the magnitude is 100 volt. And when I am writing the Kcl equation for node 1, that is the node voltage equation for node 1, I am assuming that all the currents are leaving out from the node 1 because V1 is greater than any other node voltages. That is when I am writing for node 1. So therefore the current can only flow like this. I am assuming that. So therefore it is V1 minus 100 divided by the corresponding resistance is 20 plus, because all the currents are leaving, V1 and this is at 0 potential, so it is V1 minus 0 divided by corresponding resistance is 10 plus. Between V1 and V2 we have the 15 ohm resistance, and I am assuming that the current is flowing out from the node 1, so it is V1 minus V2, V1 minus V2 divided by 15 equal to, that is all the currents leaving should be equal to the current entering, it is 0. So this is equation number 1. Now we need to write the equation for node 2. We have to write the node voltage equation. So the current moving out, moving out, moving out. Why? Because I am assuming that V2 is at a higher potential when I am writing the node equation for node 2. So between V1 and V2, we have the 15 ohm resistance, and the respective current flow is from V2 to V1. So it is V2 minus V1 divided by 15 plus, this is at a 0 potential. So therefore, the current through the 10 ohm resistance will be V2 minus 0 divided by 10 plus this potential you just see. This is the negative terminal of the battery, and therefore here the value it is minus 80. So therefore the current through the 10 ohm resistance will be V2 minus of minus 80 divided by 10 equal to, all the currents are leaving, so it is 0, and therefore this is equation number 2. Now these equations can be written as 13V1 minus 4V2 equal to 300. equation number 1. And here this can be written as 2v1 minus 8v2 equal to 240. This is equation number 2. And in your syllabus, it is clearly mentioned that solve it using the metric representation. So you have to represent in terms of matrix. So 30 minus 4, 2 minus 8, v1, v2, 300, 240. Now using the Cramer's rule, you can solve it. v1 is equal to delta 1 by delta, which we have explained in our previous lecture related to the mesh analysis. So you will be getting the answer of v1 as 15 volt, and v2 can also be solved delta 2 by delta. You will be getting the answer as minus 26.25 volt. Of course, this can again be, this equation could have also be reduced as v1 minus 4v2 equal to 120, but that doesn't matter. So now we are having the voltage values, v1 as 15 volt and v2 as minus 26.25 volt. Now our next intention is to find out the currents through the respective resistances. Now we will find the current through the 20 ohm resistance. So in this 20 ohm resistance, this voltage v1 we got as 15 volt. We had written our Kcl equation considering that v1 is a higher potential compared to all other potentials in the circuit, and therefore we have kept the current flowing from v1 to outside. Now the same way you can write it over here, 15 minus 100 divided by 20. So it is minus 85 divided by 20. You will be getting the answer as minus 4.25 ampere. That means the current here it is minus 4.25 flowing out of the node 1 through the resistance 20 ohm. This can also be said that it is nothing but a current of 4.25 ampere moving out from the 100 volt supply source. So there is now our things are correct. Even though we have assumed that V1 is at higher potential, it is being make up with the current direction which we got at the end. Now between V1 and V2, V1 is 15 volt and V2 is minus 26.25. So which is at a higher potential? 15 volt. So the current passing through the 15 ohm resistance will be I through 15 ohm resistance will be 15 minus of minus 26.25 divided by 50. So you will be getting the answer as 2.75 amperes. So that 2.75 amperes is this one. Now to the 10 ohm resistance, it is V1 minus 0 divided by 10. So that is V1 is 15. So 15 by 10 it is 1.5 ampere. So now you can also add up 1.5 ampere plus 2.75 is 4.25 ampere. Now we need to find the current through this 10 ohm resistance. So it is V2 minus 0 divided by 10. So it is minus 2.625 ampere. So when it is V2 minus 0, it is nothing but it is moving out from V2 to the ground potential. And but that current we have got it as minus 2.625. So therefore the actual direction is upward, 2.625. That current is moving upward. If it is downward direction if you are marking, then you have to write it as negative of 2.625. So now we have two currents, 2.75 and 2.625. 2.75 plus 2.625, which is reaching at the node 2. You will be getting the value as 5.375 amperes. So the current through this 10 ohm resistance will be 5.375 ampere. Let us verify it using the node voltage also. So the current through the 10 ohm resistance connected between the node 2 and minus 80 volt source will be minus 26.25 minus of minus 80 divided by 10, which is equal to 53.75 divided by 10, which is nothing but 5.375 ampere. So this we can verify it over here. So now we have defined the entire system, calculate the current through each of the branches. So now this is the total circuit showing the magnitude of each of the currents and the current directions through each of the resistances. This is how you can analyze a circuit using a node voltage analysis. So if the question is node voltage, you have to identify the nodes. One of the nodes has to be taken as the reference node, write the Kcl equation, solve for the voltages, and then depending upon the question, you can find out the currents through each of the branches and also mark the directions.